how far in development would you need to go, or would you want to go before NASA could potentially take ownership?
We want NASA to take ownership like right now. I mean, they're more than happy to have them take ownership of it, and we should just be standing back and just say, great idea, but it'll cost too much money. We definitely want to keep some involvement to it, but I think NASA really needs to own it and make it theirs.
If they don't, do you want to continue the project anyway?
Yes. I mean, basically, I don't care who owns it, as long as it gets on top of a rocket going to the moon, or Mars, or an asteroid. I just think it makes too much sense for all those types of missions to just not be used. And like I said, that's that piece that they're currently missing.
Aside from the price of a launch vehicle, how much money would it take, ballpark figure, to make the project happen for a first launch in space?
I don't have a number for that right now.
That's okay. That's all right.
I just don't have a number for that. There's a lot of things that go into it, and some of that, how much would it cost, would depend on what NASA centers were involved and how much involvement they wanted and all that. And who knows what kind of weird requirements somebody might find as we develop it.
Now, are you aware of United Launch Alliance's plans for their Plymouth mission and different missions to Phobos and near-Earth asteroids? Could they potentially, if NASA doesn't do it, be the ones to take charge and pick up the program?
Maybe. I don't know. One of the things when we got the tank from ULA, and also I've been in conversation quite a bit with the authors of the paper that gave us this idea. And one of the problems they have to face is they have to remain at arm's length about this whole thing, because their charter has some tension built in. They're expected to go out and develop new markets and do things and sell launch vehicles. At the same time, they're not allowed to compete with their parent companies. And developing something like this, if ULA were to do it and lead it, that might be considered competing. So they're sort of standing back and keeping arm's length. They've got some guys who are very interested in it and really want to help us, but at the same time, there are obligations that everybody has to be aware of. So they have to sort of keep their distance. Of course, I'm sure they'd love to sell us lots of Centaurs to do this.
Well, tell me more about what else is going on with Masten.
So, entry, descent, and landing. I briefly mentioned it earlier. It's probably our biggest growing thing that we're doing right now. Not sure how much we can talk about. We can talk about what's obviously we've already done the press releases on. Interesting little project we did with Draper Laboratories and NASA Flight Opportunities Office, where we took our GNC, made some modifications to it, and it becomes a hypervisor, or a supervisor of sorts, for other GNC systems to fly our vehicle.
What are GNNCs?
So GNC guidance is guidance, navigation, and control. Is generally the algorithms and the avionics to actually, make sure your vehicle's pointing the right direction, flying the right way, and whatnot. So what we've done was we've taken our GNC, it's proven on our vehicles, it works every time, it works great. And when you take somebody who has, an idea, well, in this case at NASA, some slightly different guidance algorithms, they want to try them out on a real flying vehicle and see how it works. So they develop their system, and they stick their GNC on top of our vehicle. It actually flies the vehicle. But our system is sitting there and watching everything that's going on very closely and saying, okay, you're getting outside of expected parameters. We're going to start ignoring you, and we're flying the vehicle and get it back to a safe spot. So, and we've tested it very extensively. Unfortunately, every time that it does what we call failover. So instead of listening to the customer's GNC, it now listens to our own. We've tested that failover extensively, and unfortunately, every single time, or fortunately I should say, every single time we had to plan on doing the failover and force it to do it. As opposed to, it's their GNC just worked well enough that, we never got outside of the mission parameters.
Good. So let's talk about Zombie for a minute. Zombie was retired, but then you brought it out of retirement in order to complete objectives that you felt still needed to be done.
So, yeah, and this comes back to the Draper and flight opportunities. It was, we're working on Zero. It's in development. It's in the test program. So we don't want to be flying somebody else's GNC because, well, even our GNC isn't actually proven on it yet. So we brought Zombie out because it's a proven vehicle and it's a real workhorse, and it met all the objectives that they were looking for. And that was, let's fly this other guidance, navigation, and control, and see that it can be integrated into another vehicle. And we were able to do all the work on Zombie, which allowed us to not have to stop our test program at Zero while that got worked out. And so Zombie sort of became the workhorse that did that. And now, at some point in the future, I understand there might be some hope of moving it over to Zero or another vehicle. But Zombie really let us iron out all the bugs and get everything done before we put it on the more expensive vehicle.
So what's the current progress then with Zero right now?
So Zero is in flight test. We've done a couple of really good free flight tests. So it's actually flown without having the tether or anything on it. We've done somewhere in the neighborhood of 80-something total flights, most of those on tether. We've had a number of problems with it. It's not been our best performing rocket in some ways, and it's mostly because we put an Aeroshell around it, and that just sort of changed all the vibration modes, and we started seeing some weird couplings between vibration and some of our instruments on board. So we've been working all those out and getting it to the point where so that created problems with landing. And we've actually gotten that down now and we can land. And so, like I said, we've done a couple of free flights. The last successful free flight was a free flight where we went up to 60 meters and came back down. And really the purpose of that particular free flight was to show me whether I had an error in my simulator or I had an error in our GNC algorithms. It turned out I had an error in the controller because it did exactly what the simulators said it was going to do.
Now, why have the Aeroshell on it in the first place?
Well, the Aeroshell is really two things. One, it actually decreases the amount of drag, so we can get much higher altitudes with it. And then two, it makes it easier to model in a simulator because it's a simpler shape, so we can run the CFDs fairly quickly, and yet we know what that shape produces in terms of aerodynamic effects. So that makes it easy for the modeling part, and it also makes it easier for us to develop controls, develop the control laws, and whatnot. So, and again, it just streamlines and makes it push through the air much easier.
Now, will the Aeroshell possibly create problems with future payloads?
So, well, I mean, there's always the problem of not having enough space. Like on Zombie, we need a little more space. Okay, we unbolt the top hat, we add another section, we can weld stuff on sticking out. But you really can't do that with the Aeroshell. But other than that, no, I mean, not really seeing any problems with that. Just never as much space as you want.
So, are you still planning on building Zogdor?
So we are planning on building Zogdor. We are actually building a second Zero right now.
Okay.
The first Zero, we've determined, we've been doing more aerodynamic studies. We've got some actual flight data to look at the aerodynamics as well. And we determined that the first Zero, the way we built it, probably wasn't going to do the 100,000-foot flights like we want. So we built a Zero B, a second Zero, which has a few more optimizations to it, and that will definitely make its target of around 100,000-foot altitude. And then Zero is actually the same body in just larger tanks. So we started the process. So how does this go? So we're in flight test with Zero. Zero B is all the parts are coming in right now. We're actually starting to assemble it. And then Zogdor is all the parts are out for quote and being worked on by our vendors.
So then, would Zero actually be able to reach higher altitudes and have heavier payloads than Zogdor?
No, Zogdor is definitely the higher altitudes, heavier payloads. It's while it fits within the same, it uses the same Aeroshell. It has a much larger engine, and it has larger tanks. It's just the tanks are actually expanded out to fill the Aeroshell.
And would that be the first vehicle that you would be reaching suborbital heights with, or could that be done with Zero?
Well, Zero, I mean, suborbital is technically any time that perigee is below the Earth's surface. So technically, every vehicle we've done so far is suborbital. But the reaching space, Zogdor actually gets to space. It gets us up to the von Karman line at 100 kilometers. Whereas Zero is about half that.